Hello, my dear students. This is Dr.M.VIJAYASANKAR, Assistant Professor, Department of Statistics, St.Joseph College of Arts and Science. Today we are going to discuss about correlation and regression. Here one example is taken for regression equations. In this problem, we are going to find the regression equations of x on y and regression equations of y and x. In previous sections, we have discussed about using data to calculate how to find the regression equations. But in this example, directly the result were given. So using the result, we are going to find the regression equations of x and y and the regression equations of y and x. From this example, in a correlation study of the following values are obtained. Correlation coefficient value is 0.8. But here the correlation coefficient value is directly given. But previous problem, in previous video, we are discussing about how to calculate the correlation coefficient from the data. But here, instead of the result is given. And I find the two regression equations that are associated with the mean 65 and 67. And its standard deviation value is also given 2.5 and 3.5. Using this result, we are going to find out our regression equations of x and y and the regression equations of y and x. But in this problem, directly the result is given. For our result values is correlation coefficient values is 0.8 and the mean of x1 bar is 65 and the mean of y bar is 67 and the mean of and standard deviation of first values is 2.5 and the another standard deviation values is 3.5. Using these values, we are going to calculate our regression equations of x and y and x. Solution. Already we know that the regression equations of x and x. Here I am once again repeat the regression equations of x and y and regression equations of y and x. That is, regression equations of x and y is x minus x bar equal to r into sigma x by sigma y and y minus y bar. And regression equations of y and x is y minus y bar equivalent to r into sigma y by sigma x into x minus x bar. Using these two equations, we are going to find our regression equations of x and y and x. In our problem, their given values are r equal to 0.8, that is correlation coefficient values, and x bar answer is 65, that is mean value of x, and y bar value is 67, and it is the mean value of y. Using this mean value and r value, we are find the regression equations. And also given sigma x value. Sigma x is nothing but standard deviations and sigma x value is 2.5 and sigma y value is 3.5. And using these values, now we are going to find first r into sigma x by sigma y, because this is very important to calculate our regression equations of x and y and x. Now finding r into sigma x by sigma y, our r values is 0.8 and our sigma values is sigma x values is 2.5 and sigma y values is 3.5. Substituting these three value in this answer, and after simplifications we get 0.5714 for r into sigma x by sigma y values. Similarly, again using this same value and finding, we are going to finding r into sigma y by sigma x. Our r values is 0.8 and sigma y value is 3.5 divided by sigma x value is 2.5. After simplifications, we get 1.12. Now we are going to apply this all the values in our regression equations of x and y and the regression equations of y and x. This is our regression equations of x and y. But previous section, we are using the data and finding x bar, y bar, r values, everything. But here directly we are going to substitute all this value in these equations. That is, our r into sigma x by sigma y values is 0.5714 and y bar answer is 67 and x bar answer is 65. X and y means we want to keep x values in the left hand side and the remaining terms and constant values should be taken into right hand side. So finally we get x and y equations. Now substituting x bar answer is 65 in these equations, and r into sigma x by sigma y values is 0.5714 in these equations, and x bar y bar answer is 67, substitute in these equations. Finally, multiply these values 0.5714 into y minus 67, and taking the minus 65 in the left hand side to into right hand side, we get plus 65. After simplification, we get 0.5714 y minus, now multiply 67 into 0.5714, we get minus 38.283, then plus 65. Now after finally subtract these two constant values. Our constant value is 65 and minus 38.283. After subtracting, we get minus 26 plus 26.72. Using this substituting these values in x on y, which is called as a regular equation. Now similar to, we are going to find y on x. Our y on x formula is y minus y bar equal to r into sigma y by sigma x into x minus x bar. Our y bar answer is 67. Substitute in the left hand side. Our r into sigma y by sigma x values is 1.12, and substitute in the right hand side, and x minus x bar answer is 65, substitute in the right hand side. Now multiplying 1.12 into x minus 65. So multiply, we get 1.12x minus 1.12 into multiply with the 65, we get minus 72.8. After finally substitute, transfer this minus 67 in the right hand side, we get 67 plus 67. Now subtracting the 67 minus 72.8, we get minus 5.8. The final required equations of y on x is y equal to 1.12x minus 5.8. This is regression equations of y on x. The result is the regression equations of x on y is x equal to 0.5714y minus 26.72 is on x on y equations, and the regression equations of y on x is y equal to 1.12x minus 5.8 is the, which is the required equations of x on y and y on x. Thank you, my dear student. Thank you for watching this video. I think you are understand these concepts clearly. Thank you all.